Okay. All right. Now, you're going to start with a short quiz. Should take about 5, or well, it says 10 minutes. Should take about 10 minutes. All right. It's going to involve 3 of these particular skills that you're supposed to be able to apply. One is the quadratic formula, quadratic equation that you're supposed to understand how to be able to look at the equation and produce the quadratic formula. Now, the discriminant is part of the quadratic formula. What part? It's the part under the square root radical. So the b squared minus 4ac, and that has a bearing on the kind of answer that you're going to end up with. If the discriminant is negative, you have an imaginary number, and in a while we're actually going to start working with imaginary numbers as well as with real numbers. All right, if it's positive, then the number's real. If it's positive in a perfect square, it's rational. If it's positive and not a perfect square, then it's an irrational answer. Okay? Now, then the vertex also comes from the quadratic formula. Okay, where does the vertex information come from? Negative b over 2a. Right? And that gives you the x value of the vertex. The vertex is the peak point, either the highest or lowest, depending on the equation. And if you have the x value of the vertex, that's the line of symmetry. If you put the x value into the equation where the x is, it'll be squared in the first term and not squared in the second one, you can find the y value.
Oh wow, I forgot.
Okay? Alright, so that's what your quiz is going to be over. So if you're watching this by video, you need to turn the video off now and do that 10-minute quiz and then turn the video back on. Okay, but we're going to continue because we're out of compressions. Now. Okay, so here's what we're going to look at this week with the time we have remaining. All right, we are going to be looking at, all right, I've already collected the test, right? We're going to look at some chalkboard examples for 5.4, 5.5, and 5.6. All right, we're going to cover that. Your assignment for this week is 5.4, 5.5, and 5.6. All right, now, there is, on page 224 and 227, there is, I think it is a 10-question cumulative quiz. All right, that is going to be assigned to you as a project, which is going to be due in 4 weeks. Now, if it's 10 problems, either 9 or 10 problems, if it's 10 problems of review work and you have 4 weeks to turn it in, start it now. Start it now, right? Now, one of the problems I am seriously thinking about discarding, or either that or we may have part of our class next week that talks about that particular problem. Because to me, it doesn't flow with what we've already done on that skill, and so I'm probably going to address that. All right, but I will remind you this week and next, and I'm going to give you a date that I want the project turned in. Yes, ma'am?
What page did you say that were on?
I didn't say. It says here 224, 227.
Okay.
Okay. All right, so just be aware that you're going to have a project. That project is going to be graded. It's basically an open book review test. But in December, our last class in December, you're going to have a test. And it's going to be over the same material that's on this project. All right, and so you have a chance to review, find out what you don't know, and then ask questions. Yes, ma'am?
Will we have an extra credit thing? Will we have anything for extra credit for the midterm?
I don't think so. Personally, I've inherited some extra credit problems. I don't necessarily like extra credit problems because I would rather see you learn to do what you didn't know how to do when you took the test. Right? And then I'd rather see you get points back because you've improved your understanding than not know how to do this and do some other project that you already know how to do in order to be able to compensate for it.
Yeah.
Right? To me, it makes more sense because what you're doing is you're trying to learn the skills that are in this text, and there's lots of them.
Right.
Okay, so to answer that, I don't know, but you know, so far, I think we've given 4 points of extra credit from everybody because we don't know how to do those problems yet.
Right.
Okay.
The one
Right,
quiz that you gave to a take-home was really easy, though.
Yeah.
The last one.
Yeah.
Yeah. Good.
It's so easy. I got that.
Good. Yeah. Because that extra credit was on stuff we've already covered.
Yeah.
All the rest of them are stuff that we're about to cover. Okay. All right. So here's what we're going to work on right now. The first thing that I want you to put in your notes is imaginary numbers. Now, I usually, when I teach Algebra 1, I go over imaginary numbers in Algebra 1 so that when we get to this point, my students already understand something about it, and it's not scary, because it's not, right? But it's also not unfamiliar because we'd already looked at it in Algebra 1. Okay? So, imaginary numbers, by definition, the square root of -1 is going to be called I. All right? Now, when we were looking at the discriminant, if we had a negative value for b squared minus 4ac, we said there's no answer. There's no answer in the real number system. But if we define the negative as I, then we can continue working, only the number, instead of being in the real number system, is going to be in the imaginary number system. Okay? So, let's look at that. Okay? If we came up with the square root of -36, right? The square root of -1 is I, and the square root of 36 is 6. And so the square root of -36 becomes 6i. Now, 6i is what kind of number? Starts with I. Imaginary number. It's not real. So you can't combine a real number and an imaginary number. They have to stay apart. Okay? Now, suppose we had a square root of -15. All right? The negative sign becomes an I, but because this is not a perfect square, we would just have square root of 15. Now, some people and some teachers like to have the I first. Others like to have the I second. Here's the problem. Over here, is that I under the square root radical with the 5?
No.
Or not? In this case, it's not, but what happens if you write it where it's under? Then we have confusion. So that's why some teachers do it this way. I don't care. Most of the time I do it this way. Right? So, square root of -45. Okay, now this one, if you haven't done a lot of square roots, this one's important to you. What's the negative become? An I. Okay, that part's easy. You should all get that. We could teach a 3rd grader to do that one.
Yep.
Right? Okay, now, square root of 45 has a perfect number in it. It's 9. What's the square root of 9? 3. And what's left? 9 times what is 45? 5. And so the 5 still stays under the square root. All right, that's simplifying the square root.
Awesome.
Okay, in this case, simplifying an imaginary square root.
It's getting
Okay.
special.
All right. So now, is the I really a tough concept? The answer is no. The square root, if you didn't have a lot of practice with square roots, the square roots might cause you a problem. But here's the thing that you do. You look for a 4. Why? What's the square root of 4? 2. And so I want to take this number and see if it has a 4 in it, because if it does, I can separate it into the square root of 4 and the square root of whatever's left. All right? If I don't have a 4, then I look for a 9. Why? Because if it doesn't have a 2 in it, in order for it to have a 3, you have to have the square root of 9. right? Now, I don't have to worry about 16. I'll find a 16 with a 4. So all I have to do is look for 5. In order for it to have a 5, it has to have a 25. So you look for a factor of 4, a factor of 9, and a factor of 25. If not, then it's probably going to already be in simplest form.
Alright.
Does that make sense?
Yes.
All right, so when you begin to break those out, if they ask you to simplify a square root, there's usually got to be one of those in that product. Otherwise, you can't simplify it. Right? So you look for 4, you look for 9, and you look for 25s. All right, so the easiest one, the square root of 75. All right, 75 is 25 times what? 3. And so the square root of 25 is 5. The square root of 3 is still square root of 3. And so the square root of 75 becomes 5 times the square root of 3.
Right.
What would square root of 50 be? It's 25 times 2, right? So it's 5 times the square root of 2. Right? It's real simple. It's simple. But if you understand that that's all they're asking you to do, then it's not terrifying. It's just a piece of work that you have to do for school, which is called schoolwork. Schoolwork. Okay? All right? Okay, so, all right, now we're going to look a little bit deeper into I. All right, and I thought I could get that. Let me see if I can get this. What happened here? All right, there you go. That works out. Okay, now, if I is the square root of -1, then I squared is the square root of -1 squared. And the square root of a square is the number under the radical.
Okay.
Right? Because the square root is the half root. What is half of 2? 1. That's the power right here. The power right here is 1. And so this is -1 to the first power, which is -1. Right? The square root is the half root. This is the half root times 2 of them. All right, 2 halves is 1 whole. So this is the whole number here, and it becomes -1. So this is important for where we're going with imaginary numbers. Because if we FOIL with an imaginary number, we're going to have I times I, which is -1.
Yep.
Okay, that's going to be important. Right? I times I squared is the same as -1, and so when you see the I squared, you're going to have to change it to a -1.
Right. I got you.
Okay? Now, so then you have something that we're not going to get into in this book yet. Then suppose that I take I to the third power. Well, I to the second power is -1, but I have one more I, because I have 3 I's, right? So there's 2 of them here, and there's 1 of them here. This is -1, so I to the third power is -I.
Okay.
Okay? Now, that's abstract. Right? That's weird. It's strange, but it is what it is. Okay? Now, is it some number to the 4th power, the second power times the second power? Right? Think about it. The 4th power, if I have a to the 4th power, I have a times a times a times a. That means I have a to the second and a to the second.
Right.
And whenever you multiply powers, you add the exponents. So if this is I to the second power, it's -1. The other 2 is -1. So I to the 4th will be -1 times -1, which is +1. Okay? And so I can't use this pencil because it's dead. I to the 4th power will equal +1. Because 2 of them is -1. That's 2 of these. And the other 2 are -1. -1 times -1 is +1. Okay? And then after you get these 4, when you get to 5, you have these 4 plus 1. So it's going to be I. If you have 6, you have these 4 plus 2, and so it's going to be -1, and you can actually, there's a problem that you'll get on testing that'll ask you for what is the value of I to the 25th power. Okay, now, every 4 equals a +1. So how many 4s can I get out of 25? I can get 6, right? With how many left over? 1. So the 24 of them will give me +1, and I have 1 left over, so the answer is I. See? Isn't it cool? And so that's just fun, right? But the whole key to that is understanding these first 4 powers of I. So I is the square root of -1. I squared is -1. I to the 3rd power is -I, and I to the 4th power is +1. Right? And you just have to learn that. Just like, what is 2 times 2?
4.
All right, you have to learn it. Right? When you were 2 years old, you didn't know 2 times 2 was 4. Okay? All right, now, so then we talk about what's called complex number. All right? Complex number has a whole number and an imaginary number. And it's called what? Complex. All right? It's complicated. Can you add them together and get 8i? No. Why? Because imaginary and whole number systems are different systems. You can't combine them.
So that problem is already simplified.
This expression is in simplest form. Yes. Now, if I would have had, if this would have been a 6, then I could have said 2 times, if this were 6, I could have said 2 times 3, oh wait a minute, I have to say 3, sorry. 3 times 2 plus I. I could have done that. If that were 6, right? So you can still pull a common factor, but you cannot combine the I with the real number. Okay, good question. All right, now, conjugate complex numbers. All right, conjugate, I just was tutoring an Algebra 1 student, that's where they are right now, is conjugates. A conjugate is a binomial, 2 parts, that are only different in the sign between the numbers. This is a plus, this is a minus. They both have a 2, they both have a 3i, but one is positive, the other is negative. All right, that's the term, that's what conjugate's talking about. All right, so the conjugate complex numbers, all right, if you FOIL this, first times first is 4. What is last times last?
9.
Right? It's 9i squared. Right? 9i squared. That's this number. Now, the inside is 6i. The outside, -6i. 6i minus 6i be 0. So there is no middle term. It's not a trinomial.
We love it.
All right? Okay, now, however, what's the value of I squared? -1. So this means that I have -9 times -1, which is 9 plus, or
9.
so therefore it's 4 plus 9, and the answer is 13. Okay, now the reason that you need this is, yes, you should write this down. You are not allowed to leave an imaginary I in the denominator of a fraction. Just like you're not supposed to leave a square root in the denominator of a fraction. In order to be able to get it out from under the denominator, you have to multiply by the conjugate. And when you multiply by the conjugate using I, you'll end up with this number plus that number. All right? So this skill is used, this is a testing skill for moving on to the next level. So you're going to see that as a as part of your Algebra II final, right? And you're also going to see that in any type of math testing for higher level learning. Is that you have to understand how to take the conjugate in order to be able to get the denominator free of either square root or imaginary number. Okay? All right, so does that make sense? All right, now let's look at the normal thing that happens. Okay, and that's this. Complex binomials. All right, now this foiling is done just like you would foil with a variable, with an x or a y, except that when we get the I squared, we know that I squared is -1. It's going to make that's the only difference.
See, this is so easy. All right.
Okay, so we have 4 times 5, 20, right? And then 4 times -7i, -28.
That's right.
Now, 3 times 5, 15i. And then 3 times -7 is -21i squared. But because I squared is -1, this is going to become plus. So I have 20 plus 9. Those are both real numbers. And then I have 28, -28 plus 15, which is -13i.
29 minus.
So these two can be combined. But I can only combine these two together to get -13, and so my answer of multiplying these two binomials becomes this complex number.
It makes so much sense.
Okay? Yeah, and it's different, but it's not hard.
Yeah.
Right.
Right? And this builds on what you already know about foiling and about, it's called binomial multiplication, with the exception of you now have an I squared that allows you to simplify that last term. Okay, now, if you did not know about this, there is no way you could guess the right answer given a multiple choice test. Impossible, because it doesn't make any sense. You know, a lot of times when you look, you can see the numbers, and you can think, well, maybe these two will be this number, you know, if you combine them. You know, sometimes you can figure this out. You can't figure that one out at all.
Yeah.
There is no way that these numbers right here equal 29 and 13.
Right.
You can't figure. But it wasn't hard, was it, Hannah?
No.
It wasn't hard to do. It was just, again, it was math work.
Right.
Right.
It's not bad
No, it's not. It's just another skill to learn.
though. Right.
That's all. It's not hard. But the neat thing about Algebra II and Algebra III and trigonometry and things like that is that after you learn them, they're not as hard as they are scary looking when you don't know what to do.
Exactly.
Now, they are scary looking, without a doubt. But the real math involved is not as difficult as what you think. But if you don't know what it is, it's impossible to do anyway. You know, if you don't know that 6 times 7 is 42, it's going to take you a long time to do a multiplication problem. Right? Because what do you write down? See what I'm saying? You don't know what to do, right? So, but the same thing is true here. If you don't know what to do, if you haven't learned how to FOIL, you don't know what to do with this. If you do know how to FOIL, then you have to only learn what to do with that I squared. And that's why it's easier.
Right.
Okay? Questions? All right, so that's part of the chapter that you're about to do for this week. That's your assignment. So what I've tried to do is give you a base concerning imaginary numbers from which you're not even going to do all of it, but from which you should be able to interpret what the book is asking you about negative numbers and about imaginary numbers. Okay? All right, now, next part. Wait, first of all, any questions? And, any questions over here? Make sense? Okay, good. All right, now, next part. I have not seen this in the textbook so far. And I'm getting concerned.
Oh no.
I'm getting concerned because this is important. So we're going to pick this up and let me
Did we
see
do this last week?
if she gave me. Yes, I did it last week. It's still not in the book.
Oh, yeah,
So,
yeah.
I remember this.
Yeah.
Yeah. This
Because
is
when I look at it, it's not confusing.
okay.
No, really.
All right, now, what this example is with letters is a completing the square example.
Yeah.
Is that this is what you have left after you've completed the square, right? And we know when this is a negative sign, the x value of the vertex is going to be whatever that number is. So it's the opposite of this presentation, right? If this were a plus,
Opposite the same.
then I would have minus negative, and so I would have a negative number. And then the k that was over on this side, we moved it to that side. Because most of the time, our presentation has y equals or f of x equals, and the number that's here ends up over there. And I told you that last week. Now, the size of the graph, as far as stretching or compressing, comes from what value this is. Most of Algebra 2 starts with x squared. So what's the a? 1. Right? If it starts with x squared, the number in front of the x squared is a 1. It's in stealth mode, right? You can't see it, but it's there. It's a 1, right? And so when the a is a 1, then you have a parent graph of x squared. So if x is 1 over 1, then you go square it, up 1. If x goes over 2, then you square it and go up 4. If x is over 3, then you go 3 squared, 9. Right? So that's the size representation that comes from what this number is. Now, hk becomes the vertex. We can also find h by doing negative b over 2a. That's what we just talked about. Right? And then if I take the value of this and I plug it back into the function, I can find the y. Right? Now, the k takes the graph and moves it up and down. Because if that wasn't there, the y value would be whatever it is, right? If I put a plus a number here, then what happens to the y value? It goes up whatever that number was. The x doesn't change, but the y will go up. And if this is a minus, then it goes down from whatever it was. So that becomes a vertical shift up or down, depending on what that number is. Now, the horizontal shift inside is backwards. Because what happens is you consider what does x have to be so that this becomes 0. So if this is x minus 4, then I have gone 4 in the positive direction. So that when I go minus 4, I'm back at 0 again. Okay? If this was x plus 3, then that means I started off at negative 3, so that when I added 3, I got back to 0.
Right.
So that's a horizontal shift in the opposite direction, left or right. All right, now that's a presentation of the vertex form of a parabola. Now, what have we been using? That's what we've been using, right?
Yes.
It's called the general form. It's called the general form.
Right.
All right, and if I wanted to change this form into this form, I would first of all have to factor an a out of both of these two numbers, right? And that a would become this. And then I would take half of what's left and produce this. And then I would add whatever new number so that I didn't get a change of anything. And that would become my k instead of my c. Right? So what we learned in completing the square, starting with this, we ended up with a form like this, which is called the vertex form. Right? Yeah. that sort of gets those things that we've done and puts them into perspective on how they work.
Yeah.
Yes.
Okay. All right, I see people are writing. The reason I stopped is there's people are copying this down, which is good. Okay. I spent 3 hours last night doing this.
Good job, Mr. B.
job.
Thank you so much.
So we appreciate it. We really do.
All right, got it? Ladies, can I move on? Almost? Hope you're getting it down too. By the way, if you find at the end of things to send cards and letters, at the end of the video you find an address, please send cards and letters to that address. Okay. All right. Okay, next. There it is right there. There it is right there. Okay, so what is this? It's the standard form. Okay? Now, what we're going to do now is we're going to assume that we are given 3 points on a parabola. And that we have to come up with the equation of the parabola. Now, let's stop and think. We're going to go back to Algebra 1. Now, this is important, so don't copy right now. I want you to stop copying so you're listening. All right. Back in Algebra 1, if you were given 2 points only, if I gave you 4, 7, and 3, 9, could you write the equation of the line that goes through those 2 points? All right, we know y equals mx plus b, right? I have an x and a y. I can use either one of those points. What's the m represent?
Slope.
Slope. How do you find slope?
X.
All right. Start here. The y goes up 2, and the x goes down 1. So my slope is -2. So I have, for a y value, I have 7 equals -2 times 4 plus b. Right? How much is this? -8. Add it to both sides. I get b equals 15. Now, suppose I use this one. I would have 9 equals -2 times 3 plus b. What is -2 times 3? -6. Add 6 to both sides, and you still get b is 15. So now I know that y equals -2x plus 15 is the equation of the line that goes through those 2 points. Now, most of you have probably forgot how to do that. All right, you shouldn't, because that's always testing. All right, testing for Algebra and Algebra 2 usually includes a problem related to that. Okay, now, what we're going to do is we're going to be given 3 points that are on a parabola. Okay, so it's not quite as hard in one respect because we're not having to find 2 things, we're only finding 1 equation, but the problem is we're going to have to use a 3 equation matrix to be able to find it. That's why you had matrices to begin with.
Yay!
Okay, so let's look at this. This point, and this point are all on the same parabola. That means the A and this x is right here. The B and that x is right there. The C I don't know. The value for y goes where the 0 is. So if I do that, I have A times 1 squared plus B times 1 squared, because that was 1, plus 1C equals 6. All right, and I have just started that. Now, how many variables do I have? 3. That means I need 3 equations. So they gave us 3 points, aren't they nice?
So kind of them.
Okay. Now, so now let's do the same thing with 3. If this is 3, what's 3 squared? 9. Being Okay? All right? And this would be just plain 3 times x plus c equals the y of 26. And now the third one is negative 2. What's negative 2 squared?
4.
4. Right? That's there's your 4. Right? And then minus 2b plus c equals the 21. Okay? So, what I get when I do that, let me see, let me set it right there, is I'll get this matrix. 1, 1, 1, and 6. 1, 1, 1, C, and 6.
Right. Oh, I understand this.
9 squared, or 9, 3 squared. 9, 3, 1, and 26. 9, 3, 1, and 26.
Right.
Then 4, negative 2, 1, and 21. 4, negative 2, 1, and 21. All right, now I have a matrix C with 3 equations, 3 variables, plus the answers. And now I'm going to use those skills that we've already just done. All right, now, what's nice about this? You will always have 1, 1, and 1 for C.
Fantastic.
So, instead of having the identity matrix look like this, because I can get the answers here, I'm just going to change the identity matrix to look like this. And now, the first line, when I'm finished, the C will equal that number, the B will equal that number, and the A will equal that number. Okay? So, with that in mind, I can do this real fast. How do I get a 0 here? I take this line, subtract this line, and put it in the second line. So the first thing I do is copy the top line, because I'm not going to change it right now. And then I say 9, subtract 1. 8. 3, subtract 1. 2. 1, subtract 1. 0. And 26, subtract 6, is 20. And then do the same thing with this row, subtract this row, and put it in the third place. 4, subtract 1, 3. Negative 2, subtract 1 is negative 3. Then 1 subtract 1 is 0. 21 subtract 6 is 15.
Cool.
Right? And if I wanted to, I could use Kramer's rule to find A and B.
Let's do it.
No, we're going to do the matrix.
Okay.
We're going to do the matrix. Okay? Questions about that? Pretty straightforward. And because of this value for C, this is a whole lot easier than the ones we did before, because we had to find the 1. Right? And this one, the 1s very comfortably are given to us so we can get started in a hurry. And if you wanted to, if your time was of the essence, you could then use these numbers to find the A and the B using Kramer's rule. Okay, but we're going to continue working. All right, now, I look at this, and I look at this last row. What do you see there? See, what do you see? What times table are they both in?
5.
So if I divide both by 5, I'm going to have 1 and 3. That means that A is 3.
Cool. Yep.
Okay? Right? And so that's the first thing that I'm going to do because I found it. Alright? I'm going to go ahead and make that division and rewrite my third equation to 1 and 3. Now, I got to get a 0 here. How do I do that? I take this row, subtract the row under it, and put it in as a new top row. The reason I have to do that is I want 1 minus 0 to be 1. I still want the 1 here. Okay? So, we're going to go 1, subtract 4, negative 3. 1 subtract 1, 0. 1 subtract nothing, 1. And then 6 subtract 10, -4. All right? Copy this row, copy this row. Because I haven't changed anything else. Okay? Now, I need a 0 here. I need a 0 here so I can find out what b is. So how do I get a 0 where the 4 is? I have to take this row, multiply it by -4, and then add it to the row above it. Will that give me a 0?
Yeah.
So, -4 plus 4, 0. 0 plus 1. -4 times 0, right? 0 plus 1 is 1. 0 plus 0 is 0. And now, -12 plus 10, -2. And guess what I found? A, B, and C. My B equals -2. So then the only thing I got to do is get a 0 right here. How do I do that? I take this one, multiply it by 3, and add it to that one. Alright, so 3 times 1 plus that is 0. 0 plus 0. 0 plus 1 is 1. 3 times this is 9. 9 plus -4 is 5. And now my A is 3. My B is -2. My C is 5. And so there's my A of 3. There's my B of -2. And there's my C of 5.
All right.
Okay? Now, does that take time? Oh, yes.
Yes.
Yes, it does.
Way too much.
Now, you're going to get that not in the homework tonight, but in the homework that you're going to see for 5-7, which is next week.
Okay.
But your teacher has given you
Oh my
a
God.
summary
Oh my
of
gosh.
how to do that.
I'm gonna cry.
It's like a cheat sheet.
You're so much. You're amazing. Thank you.
All right.
Saved my life.
Okay. Now, obviously, I've done some of the work for you, but why? So that you can see the process. In the case of finding the quadratic equation, the process is much more uniform than it is for the ones that we have. Golly, it's hot in here, isn't it?
It is.
It was cold and outside. It was beautiful.
So if I put this on 75, which is not fun,
Oh my goodness, who did that?
I don't know.
Not, it
I
doesn't.
can't move it.
Watch it replay.
Oh, it's on 85. Good night.
I know, you said, we don't love us to watch each other.
All right.
85?
It was on 85.
Oh, jeez. It was
Wonder
I
if
was gonna say, I thought it was pretty close
All right,
to here.
now.
I'm like, you're not wrong.
Okay, that's all of that one.
Well, it is.
Not bad.
24. We still got 5 minutes?
No, we end at 25.
We end at 25. We have 1 minute.
Your
Okay.
week starts at 30.
All right. So if you take that equation, and let's just say that it was 3x squared minus 2x plus 5, I think it was. Okay, where's the vertex? Where's the vertex? The vertex, remember the letters, is at negative b over 2a, which is going to be 2 over 6.
Right?
So that's 1/3. So the line of symmetry is going to be at 1/3. Now, if I put 1/3 into here, I can find out what the x value is.
Yeah.
All right, and this would be 1/9, so that's 1/3, and that is minus 2/3. 1/3 minus 2/3, negative 1/3, and that's 15. So 14/3 would be up here. just a little bit below that. Okay? So, this is 3. If I go over 1, I go up 1 times 3. And it's symmetrical, so I'm going to be right there, and that graph is going to look like this.
Gotcha.
Very skinny. Okay. Now, we haven't got there. All right, what you're responsible for in this week is that you're going to continue finding the x values and determining the vertex. And then next week, what we went over here just last with the 3 equations, then you're going to pick that up next week to find the equations. And by the time we get done 2 weeks from now, we should be able to plot any equation that we're given.
Okay.
Okay? All right, thank you for your attention.
Thank you.
Good day
Thank you.
today. All right, bye-bye.
Back to